Hello, EmacsConf. Today I'm here to introduce you to the Emacs Reader. It is a general-purpose document viewer that lives inside our beloved Emacs. It tries to prioritize memory and performance efficiency as much as possible, even when you're using a lower-end hardware. And most importantly, it tries to do things in an Emacs manner. That is, it tries to integrate with existing packages as much as possible instead of reinventing the wheel. And architecturally, it tries to take the advantage of dynamic or native modules, which were introduced back in 2015 into Emacs. You would ask, why exactly do we need another document viewer in Emacs? Don't we already have the built-in doc view and the notorious PDF tools? Well, the built-in doc view has unusable latency, and I'm going to show you this later when I compare this with Emacs Reader. And the famous PDF tools has actually multiple issues. One, it is extremely memory hungry, regardless of what kind of PDFs you're reading. And well, it can only read PDFs. Poplar, the library which PDF tools uses, is actually suboptimal, especially relative to MuPDF, which is what Emacs Reader is based on. PDF tools is also extremely painful to install. If you've ever installed PDF tools, you know that it has a bunch of dependencies, including a server that is supposedly packaged across package managers, system package managers. So it's extremely difficult to install and painful to install. And of course, PDF tools since the last couple of years has not been maintained as much. There's huge PRs that have been unnoticed and unmerged. Architecturally, Emacs Reader takes a distance from both doc view and PDF tools. So how doc view works is that it basically wraps around a tool called MuTool. MuTool is actually a command line tool from MuPDF itself. It relies on MuTool and a bunch of other similar command line tools, and basically makes process calls from ELISP to these CLI tools. That's how doc view works, and that's why it sort of has latency issues, because that's the best you can do by literally calling CLI tools and outputting the images into Emacs. How PDF tools works is that it tries to have a server client model. So the client is Emacs and the server is basically something they call ePDF info. It's supposed to render the images using Poplar and then send the images to Emacs, which then tries to display. I think the server client model is terrible. One, for latency purposes, and two, it makes things unnecessarily more complicated. Here is where we come and introduce dynamic modules. So Emacs Reader is based on the concept of dynamic modules, which I'm going to talk about in a bit. But how it works is that we have C modules. So we have the Emacs module.h, that's the dynamic module header, which every dynamic module package must have. And then we have our C files. And these C files essentially define functions that are going to be used in Emacs, but in C. We then load these C modules using simple require in our ELISP modules. And then whenever we call something in the Emacs runtime, say I'm going to open a file, a PDF file using find file or read or open doc, what it does is that it tries to use one of the functions that is wrapped in ELISP, but actually tries to call a function in C. And then the C module is actually going to make calls to the MuPDF. And here the MuPDF system package, this is actually a system package that is dynamically linked to the C modules. So we're basically just using it as a shared library. So you have the fz load page, for example. It's a MuPDF function that we're going to be using in the C modules. So it's going to make a shared dynamic call to MuPDF and then render the page and then show this to Emacs. This pipeline, I argue, is much better and leaner and efficient than a server client model. One, because we don't really need the server client model. So back when Politza first introduced PDF tools, that was like 10 years ago in 2015, the concept of dynamic modules were not integrated into Emacs. I think they came around like 1 or 2 years late, 2017. So that's the best he could go with. We don't really have to today, because since we can use MuPDF as a shared library, which can render things in real time and just give us the rendered images, which we can then display, there's no reason for a server to produce things for us. So that's the main architectural difference that Emacs Reader introduces compared to PDF tools and DocView. Well, what exactly are dynamic modules? Well, I can't really give you a full-fledged explanation, but essentially dynamic modules let you evaluate native compiled code in other languages like C, C++, Rust, that behaves like regular Emacs Lisp. So when our Emacs C modules, the render core C or render theme C, when all of these are compiled and they're called from the eLisp modules, they behave like eLisp, even though they're as fast as C function because they're compiled C code. But you essentially call them just like eLisp functions. You can find them using Control-HF and so on. So you can call any function from any language that supports CABI, which is virtually everything, without leaving Emacs and without losing any performance. This is extremely helpful when you want to use existing libraries like MuPDF or any other cryptographic library that is written in C, and you don't want to rewrite the entire thing in eLisp, but you can just use it as a native library. You can read more on how dynamic modules work and how you can write one in this blog. This is something that I wrote myself just after starting this package, and that will give you a bit more guidance on how to use dynamic modules more efficiently. I think dynamic modules should be used more and more in Emacs, and I think their advantages have not been exploited as much as they should. Now we're going to talk a bit about the core features of Emacs Reader. And these are the following features that we're going to talk about, and finally to talk about some challenges that we faced. First is memory efficiency. I already told you that Emacs Reader's first priority is to make sure that we are not slow and we are not taking a bunch of memory unnecessarily. So here's a graph of the heap memory size as it grows for DocView. So this is again in Emacs-Q. So this is a fresh Emacs session with just DocView, and it grows up to 900 megabytes for a very small PDF that is a LaTeX PDF, no scanned huge PDF. It's a 2 megabyte PDF. But when I scrolled from the beginning of the PDF to the end, it went up to 900 megabytes. That's the memory heap size. Does PDF tools make this any better? It actually doesn't. So PDF tools pretty much does the same thing if you look at it here. Just so if you're going to ask me, are they two different graphs or are you just showing me the same graph? They're actually two different graphs, because if you look at the DocView graph, it uses Cairo and it uses librsvg, because DocView by default converts the images into SVG. The rendered images are SVGs. PDF tools doesn't. So you don't see any librsvg calls here or anything. So this is PDF tools, and it basically takes up the same amount of memory, 900 megabytes, and exactly the same operation, exactly the same PDF, exactly scrolling from first to the last. Where do we stand? Well, we actually do much better. So let me zoom in this. So if you see, we stand at a peak of 72 megabytes. Exactly the same PDF, exactly the same operation from the beginning to the end, around 285 pages scrolled. We take much less than 80 megabytes. And actually, to be very frank, the only memory that we're storing in Emacs is not in Emacs, in the mu PDF heap is just about 30 megabytes. It's this red, dark red one. That's the cache that we're storing. That's the memory that we're interacting with in real time. And this is stuff that Emacs adds on top of it, and a bit of libmu PDF. So you can see, in terms of memory, we're saving, we're literally down what, a fraction of 10. So this was a priority for us since the beginning, because when I was starting to use PDF tools, it was unusable for me because I was on a lower end hardware, and I thought it should not be really that difficult for a document reader to not take a gigabyte of memory. It really shouldn't, because you're not really doing that much. You're just displaying images. So that's how efficient we are in terms of memory. Let's see how efficient we are in terms of speed. So Emacs Reader is actually as fast as PDF tools, and it is actually way more faster than DocView. And in some cases, it actually beats existing standalone document readers and browsers even. So let's actually see this in action. So here we are with a few Emacs-Q sessions. I'm using Emacs-Q so as to give you that this is actually as less overhead possible. So we have first DocView. All of these tests are going to be done on the same PDF. It's the documentation manual from UPDF. So if I scroll, this is fine. I'm just pressing N, and it seems to work fine. If I press and hold N, I have pressed N and I'm holding, and Emacs is stuck. And it's going to stay stuck because it's making calls to the CLI tool that I said, mu tool. And after it's done getting stuck, it's going to get back. And as you can see, if you go back, you're able to go back fine. It does not get stuck, because what Emacs does is it basically calls mu tool, like fetches a bunch of pages, essentially all the pages that you asked for it, and it puts them into the memory, and that's it. It puts them into the memory and then scrolls through it. So going back, you will most likely not have any stuck issues. Sometimes you do, because some images do get GC'd, but that's the idea. Whenever there's no image in memory, it gets stuck, and it gets stuck good. That's DocView. PDF tools is actually not problematic here. PDF tools is extremely efficient and extremely fast. So we can go through the pages without any issues. We can zoom. The zoom did get stuck a bit, but that's relatively fine. Emacs Reader is exactly as fast as PDF tools here. So this is PDF View, this is Emacs Reader. Let's scroll through the pages. As you can see, nothing is getting stuck because we're not really waiting for any tool to send us any images. We just have a little cache, and we're scrolling through them and rendering images in real time. Zooming also works fine. So with regards to this, we're in parity with PDF tools. Now, where PDF tools and actually a lot of readers have issues is when they're dealing with scanned PDFs. So we have this PDF, which is notorious for being really difficult to render, because this is entirely built with scanned images. This is the kind of PDF that you get from Internet Archive. This is essentially someone took photos of the book in a camera and literally turned them into a PDF. Emacs Reader actually does not have any issues rendering this. As you can see, it renders it smoothly and fine without any halts. I can change Emacs even while it's doing so, and it does not have any issues. PDF tools or the same PDF also does not have any issues. Sorry, to PDF view mode. PDF view is a bit slower, but does not have any issues. It works. Here, actually, PDF read tools and Emacs Reader are more efficient than even browsers. So if I try to open the same page in a browser, I'm trying to scroll, and after I've scrolled and I leave scrolling, it's going to load for a bunch of seconds to give me the page. It's more than 5 seconds, as you can see, and this is actually totally not usable. If you're going to read this book, an electromagnetics book, you're going to have a terrible time reading this in a browser, which is supposed to be the fastest thing alive. You sort of have the same experience in Ocular, so this is Ocular. If I try to scroll through this, it will do the same thing, and while it is better than the browser, it still takes a while, and it still has, like, if you zoom, you're going to have a bit of a delay. You don't really face that in Emacs Reader. We zoom in and out just fine. And even with using mouse, you can zoom in and out just fine. So this is how Emacs Reader performs in terms of speed with these other tools. Now we will go back to the original presentation. Now, how exactly is Emacs Reader able to do a lot of this? I wish I could sort of spend an entire session just talking about this, but I can't, so I'm just going to make this short. So when you load Emacs Reader, in the standard output, it's going to say this, that 8 threads have been initialized. Now, what we did with Emacs Reader is that we enabled system-level multi-threading. Now, Emacs is not multi-threaded. We all know that, notoriously. It is single-threaded. But we don't really need Emacs to be multi-threaded, though. Emacs does not need to be multi-threaded. What needs to be multi-threaded is the rendering part, because that's the most expensive part. In Emacs, we're only just displaying images. Emacs itself does not have a PDF engine that is rendering stuff. MuPDF is supposed to take care of that. So if I can do multi-threading in the rendering pipeline, that is when I'm rendering pages instead of displaying them, that's fine for me, because the rendering part most of the time, especially in scanned PDFs, is the most expensive part. So if you look at this graph, we have two parts here. We have the display pipeline and we have the rendering pipeline. In the display pipeline, we have just the Emacs session, which has the reader loaded, and that's the main thread. And then we have the rendering pipeline, which has the MuPDF system package dynamically linked. So when you load Emacs Reader, we initialize a thread pool with 8 threads. Now, what you do is, let's say we are at page 50. At page 50, Emacs Reader maintains a cache. It's like a stack of pages that we keep in memory all the time. This cache is entirely outside of Emacs. It is not inside Emacs environment. It is in the C memory heap, in the MuPDF memory heap that is outside of Emacs environment. It does not make any calls to Emacs anything. Does not have a single elisp line. So this cache is stored outside. Now when I want to retrieve anything from this cache, let's say, so I have cached up until 55, from 45 to 55. So what happens is that when you're at page 50, you always have a cache that's n plus 5 and n minus 5. So you have cache of 5 pages forward and 5 pages backward. But let's say I want to go to page 56. So I will ask in Emacs render page 56. And I'm not going to ask it to MuPDF directly. I'm going to ask it to the thread pool that do this job. And thread pool is going to assign one thread to it, let's say the thread 1, which is going to render page 56. So this thread is going to make calls to MuPDF through our code, dynamic module, and MuPDF, after rendering it, is going to store it in the cache. So we're going to add another 56 page to this. Now, while this is happening, Emacs Reader does not, like Emacs itself, the session is not going to be stuck, because we just made a call to the thread. We just asked the thread. So like this call, like it's done. So you just assign something to a thread, and then this is fine. Like you're not waiting for the thread to complete or anything. Emacs is not waiting for the thread to complete. The dynamic module or the C side might wait to complete, but that is entirely different from the Emacs session. So Emacs Reader can continue to display the page 550 while the rendering pipeline is still rendering the 56th page. And when Emacs asks to display page 56, it's going to ask it to a thread pool, to the thread pool. Then thread pool is going to assign another thread, let's say this one, to retrieve page 56 from the memory cache. And then the 56th page is going to be sent to the Emacs to be displayed. Again, the retrieval part is entirely independent of Emacs. Emacs does not have to wait for it. Emacs only needs to wait to display it. So the displaying part and the rendering pipeline are entirely asynchronous, so to speak. And in the diagram, if you see, all the arrows that are magenta in color, they are native to the Emacs runtime. That is, they are single-threaded. They are connected to Emacs. And all the arrows that are red in color, they are totally asynchronous. They can be multi-threaded and they are multi-threaded by default, because they interact only with the MuPDF shared library and the C heap. They do not touch anything in the Emacs runtime. This is how we're able to switch quickly between these huge scanned PDFs that have huge images in each of their pages, because we don't really wait for each page to be rendered. And Emacs does not wait for that. So that's another architectural feature of Emacs Reader, that we are system level multi-threaded. Now Emacs Reader also supports almost all document formats. It supports PDF, EPUB, MOBI, XPS, CBZ Comics, and it even supports other non-ebook formats like document formats, so you can open like LibreOffice documents in it, and even stuff like PPT and Excel in it, even though they're not going to be supported in a as nice manner. And we can do that because MuPDF does this. MuPDF has support for all of this, and it treats them just as it treats PDF. Nothing special. The only thing that we don't support right now is Deja Vu, so that is not supported right now. I'm going to work on making it supported at the upstream MuPDF. That's going to take a long time, but it's in the plans. Now with Emacs Reader, we also integrate with existing Emacs packages as much as possible. So bookmarks, Ctrl+X+RB, you can do it natively. So you can save a page as a bookmark, just as you save anything else in Emacs as a bookmark. There's also Save Place integration, so you can scroll a PDF, close it, and then come back to it at the same page that you saved it at, that you closed it at, and it's going to work just out of the box because of the Save Place package in Emacs that is built in. We also have iMenu integration for table of contents. So if you see this, so this is iMenu, and you can scroll through the contents just like you scroll through any iMenu. You can also do it in the menu bar by clicking, and it works just as nice. We also have something like the outline mode that PDF Tools has. So if you press O in a document, it's going to give you this outline, and these are buttons that are clickable. You can click them, you can press enter at them. And this is the menu bar item that I was looking at. If you click here, index, it's going to show you the exact same thing, but in a different interface. We also have a naive dark mode, which is not really as nice as we would like it to be, and dark mode fanatics, I'm sure, will have issues with it, but we're going to improve it in time. For now, this is what we have. And it can be enabled per document, so you can have one document that is in dark mode, but another one that is not. That is nice to have. Eventually, we're going to work on more themes. You should be able to actually integrate it with Emacs themes as much as possible. You can make it default so that it inherits colors from the Emacs theme. That is one of the things that we also haven't planned. We did face a bunch of challenges while trying to implement these features. One of the initial challenges was that SVGs were actually a bad idea. They're huge, especially in scanned PDFs, and they make things much slower. So we chose to actually have PPMs, which is the simplest image format ever possible. Now, it was also very difficult to make reader mode be window specific. So, while you're scrolling the same document in one window, the other window with the same document should not change. You should be able to have multiple pages in different windows of the same document. That was very difficult because as I told you about the cache works in an idiosyncratic manner, and we needed to make it so that each window will have its own cache instead of having a global cache for each file. That took some rewrite. And now because we needed to do this sort of multi-threading, system level multi-threading, we needed to use a specific package of MuPDF that had a bug for this, which got fixed. And that's 1.26.0. Because we did that, a lot of the GNU Linux distributions did not really have this latest package, so we had to actually package it in tree as a submodule, as a Git submodule, and that was a horror. But eventually, now I think most GNU Linux distributions already have this. The upcoming features that we have planned are, the first one is that we need to rewrite the display mechanism entirely from scratch to use a tiled rendering approach. So right now we just take an image and display it inside an Emacs buffer, just like that. But it will be changed so that the image will be displayed in the tiled manner, so there will be multiple tiles, but it'll be pixel perfect, so you won't really see a difference. The reason to do this is to implement features for text selection, actually. So we can't really do text selection without running into a bunch of memory and other issues, latency issues, if we don't do tiling. So we need to do those two things are at the highest priority right now. And then once we're done with that, we're going to support annotations, highlighting, everything that you're used to in PDF tools and org noter. And once we're done with that, we're going to also integrate with Octec and SyncTech. Because right now, when a PDF gets updated, especially a LaTeX PDF, since there is no SyncTech integration, it can't really do it nicely, and it sometimes even crashes Emacs. So that's something that we will be planning to implement. Now, from this experiment, what exactly can Emacs, the Emacs core devs, and others who are building packages can learn? Well, the first thing is that all of this should not be really this difficult, because all we're asking from Emacs is to display images in real time and update them in real time. That should not be that difficult of a thing to do, but apparently it is. And that's why Emacs's graphical interface needs to be more modular, more composable, and flexible for real-time graphics. If it is supposed to have things like, again, a document reader, something like a video editor and something like that, Emacs's graphical interface needs to grow and be more mature. And one of the things that's stopping it from doing that is actually Emacs's overlay functionality. So right now, the way we display an image in a buffer is using an overlay, actually multiple overlays. And overlays are static in the sense that if I attach to one image to one overlay, I need to have an entirely different image updated for that overlay. So I need to create another different image, change it in the memory, and then display it to update it. I can't change the image data in real time of the overlay. And that is a big issue. I've actually made an Emacs dev mailing list thread about it. I talked to Eli about it as well. And he said there's a possibility that this can be changed, but it's going to take a certain amount of rewrite. There's also issues with Emacs GC. Emacs GC sometimes leaks memory when you update images too quickly. That is, when you have a bunch of images that are getting churned out too quickly, Emacs GC starts leaking and it just goes up to like huge number of gigabytes in RAM. That's also a huge problem. The dynamic module API, the Emacs module.h header, needs to have more helpers. It's really bare bones, and I like that it is bare bones so that other languages can use it. But at the same time, I think it'll be really good if you can have some helpers that can do better memory interaction like strings and so on, which we also faced some issues with. Emacs's fractional scaling system seems to be broken across different toolkits. We have bug reports that say in PGTK and Wayland, something seems to render differently because they have fractional scaling enabled. So that's something that I think overall, I think Emacs needs to focus on improving the graphical interface pipeline to be a much more mature one. And finally, how can you contribute to the development of Emacs Reader? Well, we are on Codeberg. We are not on GitHub, sorry. You can go there, you can look through the issues and send us a PR if you're interested. The next major release is going to go to GNU Alpha. Finally, we are not yet at GNU Alpha, so you can't really do Emacs package install and install our package. You would need to install it through use package, VC use package. And since we're going to go to GNU Alpha, we request you to assign your copyright to Emacs because GNU Alpha is essentially part of GNU Emacs. So you would need to do copyright assignment if you make non-trivial contribution. You can join us at IRC at #FindMeLambda. And I also stream the development of this package bi-weekly on Sundays at PeerTube at the following channel. Feel free to join us. Finally, I want to thank Tushar, who has been persistently contributing to the project since 0.1, and I'm very, very thankful for him, for his suggestions, and for his code contributions as well. I would also like to thank Prom, who fixed a major bug in the Windows build, since I don't really use Windows anymore, so that was really nice, and for Tuis for fixing a pthread bug. I would also like to thank others who helped fix little things, who come to the stream to chat, who sort of see me bang my head across these C memory bugs. So thank you to all of those. And thank you finally to the viewers and to EmacsConf organizers as well. This is a splendid opportunity. Thank you.